This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome again to another in the series, Mastering Mathematics. My name is Karen Weston, and this is a program produced by the Ministry of Education using its EBU unit and Center for Mathematics Education in conjunction with ABS Television. Yes, our task is to make certain that we understand that mathematics is a subject that can be done by everyone. We are now still on our topic, vectors. What I did the last time was to take an aside to make certain that I incorporated and integrated my primary school children and teachers as a part of my program. So last week, yes, we paid attention to them, asking them not to panic about the project and to realize that the project is now saying, oh, my teacher taught me this in school as a mathematics topic. Where will I use this knowledge in the real world? Okay, and so I had said, yes, for your project, you'll be giving us your goal, your aim, your objective, your introduction, your method, and telling us what you learned having carried out this project, and just show us what you actually achieved in doing that project, and then give us a conclusion. If you had to go on the net or you had to use any other references, you will give us your bibliography. And please feel free to call me. If I cannot answer you that time, I'll ask you to call me back again. But you will get an answer. Not on Sunday mornings too, because that day belongs to me and my God. All right, now, here we go. What have we done so far? Okay, I said, yes, we took an aside, but we did deal with our topic, the vectors. After matrices, we went into vectors, and we did one, show you how you would write a translation given a column vector. What am I talking about? We had this, and you had this, and we had 0, and you had here 2, 3, 4. Okay, this is a short one here, and we went up the road here this time, and you came across like this, and if this was, let's say, 1 and it's 2, we would know to say, and this was the point P, we would know to say that OP, that the vector OP would have been equal to, because horizontal movement, which would be 4, and then the rise, which would give us 2. And so we write it as a column vector, and so we call it the position vector, all right? And this was said to be in contrast when you have the coordinates, all right? So we could have been given P, just the coordinate, one letter, and it's equal to 4, 2. But when we are writing it into a vector, we have to use a translation and call it a position vector. Wherever we're starting from is called like the origin. So that is why we're writing OP, and it's equal, this time we turn it into the translation part of it, which goes to 4, 2, column vector. All right, so based on that principle, we also found out that the addition, subtraction, and scalar multiplication of vectors were similar to the operation was similar to what we had done for matrices. So that we would say the things in the same positions are added or subtracted depending on what we have. So if we had the two position vectors that we had 2, 3, and it was plus 5, 4, we know right away it would be 2 plus 5, 2 plus 5, and 3 plus 4. And so then our answer would be equal to 7, 7. If we had to change the sign and we went for subtraction, so even if we had 9, 2, and it is minus 4, 5, then we would have been getting that it is 9 minus 4, and it is 2 minus 5. And so our answer would be equal to 5, negative 3. 5, negative 3. And let me just step from the board so that my people who say that they take a little longer to absorb what I'm saying can see. So we're saying if we add in two position vectors, and we have 2, 3 plus 5, 4, the things in the same positions are added together. And so we'll be getting 2 plus 5, 7, and 3 plus 4, 7. And if we are subtracting, okay, if we are subtracting, our rule would tell us again the things in the same positions are subtracted from each other, and so it would be 9 minus 4 and 2 minus 5. And of course the rules for integers etc. comes in where we're saying which number is greater, and then so we know we're getting our answer to be 5, negative 3. And then I want to say similarly now, when we talk about in terms of the vector, we usually engage with what we're calling scalar multiplication. Okay? We usually engage with what we're calling scalar multiplication. So that if I have 2 open brackets and it is 4, 8, then we know right away that this number outside is called a scalar, and everything inside must be multiplied by what's outside. So it would be equal to 2 times 4 and 2 times 8. And so we would have been getting that it is 860. Alright? So far, we have taken you into a position where we have said, in terms of vectors, we know right away it has magnitude and it has direction. And then we said right away, what can we do with them? What is the function? And we're telling you all the time that these are really used in navigation, etc. If we have to locate points and if we have people at sea, that something is happening, and we know right away that we can then just use our vectors to track what we want to find and to locate certain persons. So the Coast Guard will be making use of vectors, all right? And here again, we continue, and so we said now, so we have to know everything. When we're doing mathematics, operations are 4 principles, and it's addition, subtraction, multiplication, and division. So somewhere along the line, we see how these things come in. Again, I make no apology for this. Yes, I'm teaching for the test and for the CXC exams, because in Antigua, that is what counts as saying that a student knows mathematics, and we want to start building the foundation, building the process from there, because we also know it only takes one success for a student to know or feel that he is in control of a subject matter. And we want to give them that opportunity. Today, I want to take you into 2 more little bits for the matrix topic, which is to tell you about how do we talk about parallelism, and how do we find the magnitude or the length of vectors. So we're going to give you your little break now, and when we come back, I'm just going to show you how do we classify two vectors as being parallel, and how do we find the magnitude or the length of vectors. And with time permitting, we will take you into some of the operation of the questions from the CXC class papers. So we will be doing that and tying up vectors. We are pushing and we're feeling quite well and good, because we also want to see if we can start the topic functions and relations, telling you exactly the main things that you should be concentrating on for your examination. Things are simple, and it is a passport, it is a matriculation tool, and I want to make certain that you get it. Afterward, we learn all the mathematics that we can, fill in all the gaps that we didn't have time to do, but we know it can be done. All right? So take a little break, and we'll be right back to tell you about the property of parallelism as it relates to vectors.
The Ministry of Education, Science and Technology and CIBC First Caribbean International Bank are proud to present the second annual CIBC First Caribbean Primary School Awards. Join us and be a part of this celebration of academic excellence as we show appreciation for the outstanding accomplishments of our young achievers. It's the second annual CIBC First Caribbean International Bank Primary School Awards, Thursday, 11 December 2014 at the Precision Center in Painters at 4 p.m. Come and encourage the youth.
All right, good. So you had your break, you're relaxed, you're easing, because yes, you're up to date, because you're now saying, this person did that vector question so long ago, I hardly remember, but now you do remember, okay? You have your books, you had the time to look through, so yes, these were the notes I wrote, and I know what position vector means, because coordinate would say you have 1 point, like you would have the P, all right? So we put in a P, and you'll be finding the coordinate here. But if I ask you for the position vector, you have to give me 2 letters. Now, I said I was going to do parallelism. I'm going to step back a bit, because since I'm talking about position vectors, let us go straight to the CXC exam question and see how these questions come in with that knowledge for position vectors, okay? How do they use it? And here I have on the board for you, it says, the question here, this is from the January 212 General Proficiency Examination, okay? The 4th of January 2012, and it's the CXC exam paper. And this is question number 11, okay? Right, the last question at the back. And I want everybody in Antigua to do the vector questions and the matrix questions, because they're simple, all right? We have the information and we can do it, all right? Now, here we go. It says, and I've tried to give you a replica on the board there. This is the exam question, because you know it is done on graph papers, okay? CXC exam graph papers. All right, but yes, but the graph paper will be right here. All right, cameraman, we can just zoom in a bit and show them that that is what it looks like. So I have just drawn it on the board, and my cameraman, of course, is Jetta Charles, and yes, he's a mathematician. Sometimes you may say, Miss Weston never get anything wrong. Of course I do sometimes, but he's right on the ball, so you're not going to see any of that, okay? And that is why it is so good working in this atmosphere, because he's not just here handling the camera and pushing and doing that. No, he's a living and walking part of the mathematics that's going on right now. So he's a student, one that I can have right here, yes, as my really person who can just test everything. And while I'm doing the questions, he can look right away and say, yes, he's working with me. And he nods every time, so you know you're getting through, and you know that the thing is nice. And that is what we do, all right? Now, here we go. it says the diagram, and this is the diagram I have on the board, shows two position vectors, OA, and OB. Alright? So the vocabulary is familiar to us. Position vectors. We know what that means. Alright? We go into the examination room already knowing their position vectors. So when we're writing them, they have to be written in terms of column vectors. And CXC does not even wait for you to know or to sort out that information. CXC says, write as a column vector in the form XY. You want anything more easier than that? Telling you the question? You know how much money your mommy gave you to buy those lunches and you have your breakfast going to school? And CXC is still giving you so many things. Write as a column vector in the form XY. Right? So, what do we know? As students, we have to do our part, study. Alright? Study. And nothing comes easily. But look, CXC has given you the format and all. Alright? So I don't know what else you expect. And then it says, write as a column vector in the form XY, OA. Write as a column vector in the form XY, this OA. And we have been accustomed to see these things because we have been doing things where we are drawing things like this and asking you to tell us what is the translation vector for that, all right? And you have been doing all these things. And that is what you go in the examination room and do. Teachers are not just making up things or just occupied or just keeping you busy. They know the syllabus and so they're telling you right away. And look at CXC writing. Write as a column vector. So even if you didn't know what position vector is, they're telling you the format in which you must put it. And once you see an X and a Y axis, you know right away the X coordinate is written first and then the Y. CXC didn't even wait for you to know that. They've given you X and Y, so you know that. Alright? And you can't expect anybody to help you anymore. So students, you need to play your part. Alright? So here we go. As a column vector in the form XY, OA. And so we want to know what is OA. And what would we say every time? Horizontal movement first, because we have identified this is the line OA right here, watching us. So how are we going to get, because normally we would have put this arrowhead at the top. How are we going to get to hold that? Because it's a prize up there we want to capture. And we say, yes, this is the origin. So right, we have to walk from here and we're going strutting along here. And we say, yes, that's the grid where it is, okay? And we're stepping out and we reach here. And what do we do when we reach here? We're looking up because we know that we can see that something is up here. Right, Jetta? We can look up here and see. I don't know how to draw them and looking up, all right? We have to go and get a graphic artist. But yes, so when we reach here now, we said turn our head and we may be looking up upside here to see where we're supposed to be looking. And then when we look up here, we see, right, the arrowhead is up here. So this is where we have to walk up to get right up here, right up there, okay? And we are walking, going up as if we're climbing up some steps, okay, to get right at the top up here. And these are the grids we would be counting. So our first movement, the horizontal one, would take us from 0, and we come right along, and we see we stop at -1. So in the column vector, the first one, x will be -1. And then we say our task is not over yet. We have to climb up these steps. So we're going up 1, and then we say still have to go up here again, and we're up to 2. Yes, still climbing up. And you say you haven't reached us yet. And when you reach here now to grab our task, we say right here, yes, boss, you belong to me. And we see we're up to 3. And we're going up the rise up to 3. And we know anyway along here would be our y-axis. Here would be negative x. And this is our x-axis. Alright, so we know right away that the value of the y would be equal to 3. There is no way, if you have been in school, there's no way if you have been paying attention, you can go in the examination room and in just even half a second finish right out that answer immediately. Alright? So, and we're taking our time because we are teaching. Alright? And we understand that some people are hearing it for the first time. But students, fifth formers, fourth formers, we expect you, once you would have been taught by your teachers the vector question, that you know it right away. And you know, we have teachers over there, Anthony King, we have Mr. Lake, and we have Elizabeth Thompson, and we have at Clare Hall Secondary, Miss Bradshaw, Mr. Goodwin, at All Saints Secondary, we have Mr. Gordon, at Piers, we have Mr. Small, and we go down and down the line. Up at Glanville's, we have one of my twins up there, that he's also taking care of that too, okay? We go over to St. Mary's, and at Jennings, we have Lennon and all the group up there, and everybody's working, they can do these things, all right? Even over at Irene B. Williams, yes, we have all the teachers over there. Mr. Lake's daughter, she's there too. And we're doing the stuff. And I'm ever ready, all right? Ever ready. Over in Barbuda again too, we have Miss Mussington, and she works very, very hard, all right? Very, very hard. And we are going to surprise you this year because, oh my gosh, if I forget these names, Zena, and all these guys, I best look in my look, and I don't even have the book here because they say they don't want me to say the Barbudans, they want me to call them up, call the names because they're looking. But today I'm not calling any names because I don't think I have my book with me. But they know who they are. We work very hard, okay? And that is what's going to happen. So students, I'm encouraging you, take time, sit, and you know what? All these things too, they are on our tablets, all right? Today the internet is just not working right. I'm not showing you the exact thing right away, but every last thing. I think we have at least 38 episodes on here already, okay? And we have examination questions too. So use everything there on Facebook too. What else you want, okay? Facebook too. And we have other things where we can get all these information for you. So just access all your information. So again, this is for our slow learners who say that they're slow learners. We accommodate them too. Yes, and we accept you, but I don't want you to classify yourself like no slow learners, all right? You came into this world just as fast as any one of us, so let's go. And here we go. So we have our X and our Y axis, and we have them here on the board again. And then we're looking, and what are we seeing? The figure is right here. They've asked us for position vector OA, and what do we say? It's a horizontal movement first and then a vertical movement, okay? And then we go right over and we want to get the top of the graph, and then we see right away written in that form, and CXC has been very explicit in terms of giving you that. So we know right away that OA would be equal to -1, 3. Similar recurrence, they're asking us now for OB. And can we do that quickly? Yes, we can. Because what do we know? Horizontal. And you don't even have to say, Miss Weston, tut, tut, tut. You go right away and say, where is it ending? 5. Isn't that true? So you went, yeah, okay, let me just do it for some people who still want me to show them how to walk over here. Right. And you're walking, right. Okay. And this is where we will have to stop, because this is where we look up and see the arrow right here for OB. So we know that the first letter would be 5, and then you say, oh, I have to climb up some steps to get up here, but it's not too many. So you say, okay, this is a short one, so we're going up. Someone's going to have to show me how to draw men upside down, you know, so that the people can be looking up, okay? And so they're walking up, and we hop up, and we go just up to 1. So that OB would have been equal to 5, 1. Okay? Now, so, and that is how simple it is. That is what it is. So what do we do? Don't listen to the lying tongues telling you how exam hard. We must sit, learn our information, take them with us, and accept and we understand the principle, and that is all it is, okay? All it is. One of the most practical aspects of it. Now, can I send you home tonight and ask you, because I know some of you have done this sketch in your book, and I am asking you what would be the position vector for xy? For BA? What would be our position vector for BA? And still written in that form, x with y. And notice what they are asking for. It is asking for BA. So we are walking this time, coming from B going over to A, okay? So this is where our walk is taking us over from B going up to A. And we want to know what would be the position vector for that. And notice so I said from B to A because A to B is different, it's the opposite direction. So if they say from B to A, we have to have our arrows turned in that direction. And then we're going to come back now for you, because you remember the students were here, and we did our triangle where we talked about that every vector question can be solved using a rectangle. And we just have to say side resultant, and we can do it, and it's still an easier method. So today brought you back again on track to make you realize what are the components and the parts involved in terms of us preparing ourselves for the vector question on any CXC examination. We must know the difference between position vector and the coordinate. We must know how to find, written in column form, the translation vector when we are given one of these arrows on the diagram. Yes. And then after that, we could use the triangle to solve the other part of the vector question. For operation, we know how addition is done. We know how subtraction is done. We know how the scalar multiplication is done. All right? And that is what we have said. We're going to take our time going through some. So now we are into the exam questions. And the only two things we have to teach you again about this vector is the property for parallelism and how we find the length of the vector. And I can already tell you, you know how to find the length of the vector already because you're just using the Pythagoras theorem. All right? So we're going to ask you to review the lesson that we did today. Look again, call up your neighbors, go to the websites. Again, we remember www./ and we can go mastering mathematics. All right? And then for us, our website would be www.mathematics.info, and we can find that too. Or you just put in mastering mathematics, they tell me, and you can still get it. Okay? We have to thank Mr. Washington Bramble, who is ever ready as soon as Jetta has done his professional part of it, then he passes them over to Washington. So that's a team effort going on there. And then he can put them on the website, and we have to thank him very much for that because we're building that. We're still waiting though to get other resources to help us up to do the different dimensions we need to push the education mathematics program forward. And we know that everybody is really tuned in. And we thank you very much for doing that because that is how we're going to grow as a nation. That is how we're going to improve mathematics in this country. So until tomorrow, we will be right back. And we'll be getting right into the heart of working our examination paper. This is Karen Weston signing off and telling you, do enjoy the rest of the evening.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.